Alright, in this video here we're going to do some examples involving the law of cosines. Right, so if you haven't seen the other video that I did on the law of cosines where I explain what the law of cosine is and what the formulas are for it, you should definitely check out that video before you watch this one, because here I'm just going to use the formulas to solve some problems. Right, so I'm given this triangle here, triangle ABC, where I know the lengths of all three of the sides, and I'm asked to find all of the angles of that triangle. Alright, so one of the situations where I use the law of cosines is this situation where I know all three sides, but I don't know any of the angles. All right, so in order to solve for one of these angles, I need to use the law of cosines to do that. And for the law of cosines, it really doesn't matter which angle we choose to solve for first. So I'll just go for A because A is the first letter. So why not go for that one? All right, so the law of cosines, if I'm solving for angle A, I have to use the one that starts with the A squared. So it's going to be A squared equals the other two sides squared and added together, minus 2 times these two sides again, BC, times the cosine of the angle that matches the side that I started with on the other side of the equal sign. Right, so that's the formula for law of cosines. Remember, there's three formulas. There's one that starts with A squared, there's one that starts with B squared, and there's one that starts with C squared. Right, so and you can use any one of those. You don't have to solve for angle A first. You can solve for angle B or C. But the law of cosines, it really doesn't matter which angle you try to solve for first. All right, so A squared equals B squared plus C squared minus 2BC times cosine of A. And now I fill in all the stuff I know. Well, I know that side A is equal to 5. Right, so 5 squared equals B squared, so that's 8. So 8 squared plus C squared, so that's going to be 12 squared, minus 2 times B, so 2 times 8, times C, which is 12, times cosine of angle A. And that angle A at the end there, that's the one thing in this formula that I don't know. That's the thing I need to solve for. Right, so the first part is identifying that you need to use the law of cosines here. And one of the keys for using the law of cosines, one of the things to look for is I know all three sides, but I don't know any angles. That's a law of cosines problem. Right, so I set it up for whichever angle I want to solve for, plug in all the numbers I know. And now the next part is being real careful here to not make the mistake that students make all the time. Right? So the mistake that students make all the time is to take 8 squared plus 12 squared and then subtract 2 times 8 times 12. Let's take it like one step at a time so you can see why this is not going to work. Right? So first thing, 5 squared is 25. Right? Equals 8 squared plus 12 squared. Let me put that into the calculator all at once. So 8 squared plus 12 squared gives me 208. Right? So that's 64 plus 144, which equals 208. And then minus 2 times 8 times 12, if I calculate that real quick, is 192. So it's minus 192 cosine of A. Right, now here's the thing that students do all the time. They do 208 minus 192 cosine A, and they combine these and write that as 16 cosine of A. Right? You cannot combine those two because this 192 has the cosine A attached. This 208 does not. They're not like terms, right? It would be like if you had 208 minus 192x, right? If the 208 doesn't have the x attached, they're not like terms. You can't combine them together. Well, if this 192 has a cosine A attached, you can't combine it with a number that doesn't have the cosine attached to it, right? So you can multiply all these together, right? Because all of those are multiplying the cosine A. So those three can get multiplied together. These two over here you can add together, but you cannot actually subtract those two numbers, right? The only time you can do that is if you know this angle A, like say angle A was 23 degrees, you can put in your calculator cosine of 23 degrees and multiply that by 192 and get a number for that, and then you can actually subtract those two. That would be fine. But if I'm solving for this angle and that's my variable right there, I cannot subtract 208 minus 192. Right? It's a real common mistake I see students make on a problem like this. So be careful and don't make that mistake, because if you do that, then everything else you do from here on out is going to be all messed up. All right, so I can combine the ones where I'm just squaring those numbers and adding them. I can multiply these, but I can't actually subtract them. All right, so what I need to do now to solve for angle A, I need to subtract this 208 to the other side of the equation. All right, so 25 minus 208, I should be able to do this stuff in my head, but I'm feeling kind of slow today. So is negative 183. So I get negative 183 equals negative 192 cosine of A, and then I divide both sides by negative 192. Right, and that's how I get that cosine A by itself. Now the negatives here are going to cancel out and make that a positive number. So what I end up with is cosine of A equals 183 over 192. right? And notice, I don't actually divide those. If those are going to come out to a nice number, like if it was 2 divided by 4, I would just simplify that and make it 1/2 or 0.5. But 183 over 192, I'm pretty sure that's going to come out to a pretty nasty number, and so I'm not even going to bother to divide that or try to simplify it. I'm going to leave it just like that for now. All right, so I get cosine of A equals 183 over 192, and now what I need to do is solve for angle A. Right, so don't make this other mistake that students make all the time. Don't say, okay, so I do cosine of 183 over 192, right? If I'm trying to solve for an angle, I need to use the inverse of the trig function, right? The reason I do that, to get the A by itself here, I need to cancel out that cosine function. The way I cancel out the cosine function is by using the cosine inverse, right? So I do cosine inverse on both sides of the equation, right? Which means the cosine inverse here cancels out the cosine, so angle A is going to equal the cosine inverse of 183 over 192, right? And if I do that, so I do second cosine on my calculator to get the inverse function, right? So I get cosine inverse of 183 divided by 192, and that gives me 17.6, right? So angle A is going to be 17.6 degrees. All right, so I have solved for my first angle in this triangle. All right, so that's how we use the law of cosines to solve for an angle. All right, and just to show you what I typed in there, right? I did a cosine inverse of 183 over 192. And that's why I didn't bother to divide that earlier, like when I did 183 divided by 192. I didn't actually divide that because that would have given me some weird decimal number. And then over here, I would have had to type that weird decimal number in the calculator. It's a lot easier to just leave that as a fraction. And then when you go to do the cosine inverse, just type that fraction in. All right, so just a little something to make the computation a little bit easier for you. So that's what we do, right? So we plug in all the numbers that we know. We don't know cosine of A. So we start simplifying. Remember, you cannot combine these two because this one's attached to the cosine. So you subtract this, you divide that over, and then you have to do the inverse cosine function in order to solve for your angle. Right? So anytime you have a triangle that you're going to use the law of cosines, when you have 3 sides and you have to solve for an angle, you're going to do those same algebraic steps every time. Right? You're always going to plug in the numbers, add these, multiply those, subtract this, divide that, cosine inverse. It's those same steps every single time. All right, so I got angle A is 17.6 degrees, but I was asked to solve for all of the angles in this triangle. All right, so now I've got a choice. Let me erase all this stuff. I could go and do exactly what I just did here and set up the law of cosines to solve for angle B, and then do that again to set up the law of cosines to solve for angle C. And if you're comfortable with the law of cosines, by all means, just go ahead and do that. Like I said, it's going to be those same algebraic steps every time you go through one of these problems. So you'll just be going through the motions and doing all that stuff again. But once we get one of our angles, we do have another option out. We can use the law of sines. Because now I know one of my angles and its opposite side. So now I can use the law of sines to solve for another angle. All right, and the angle I'm going to solve for here is the smaller one, which is going to be angle B. And I know angle B is going to be smaller because angle B is opposite a shorter side than side C, right? Side B is 8, side C is 12, which means angle B is going to be smaller than angle C, right? The sides of a triangle, the longest side is always opposite the biggest angle, right? The shortest side is always opposite the smallest angle. That's the way it works in triangles, right? So when you're using the law of sines to solve for an angle, I may have mentioned this on the videos that I did on the law of sines, so you might want to check out those videos. But just in case I didn't, whenever you're using the law of sines to solve for an angle in a triangle, you never want to use the law of sines to try to solve for an obtuse angle, an angle that's bigger than 90 degrees or might be bigger than 90 degrees, right? So if I have a choice of which angle to solve for, I'm going to solve for the smaller angle first. And I'll show you why that is after we do this. So if I do the law of sines, it's going to be the sine of 17.6 degrees over its opposite side, which is side A, which is 5, equals, and then my smaller angle is going to be B because it's opposite the smaller side between the B and the C, right? So it's going to be the sine of angle B over side B, which is 8. Right, again, when you're using the law of sines, go for the smaller angle before the larger angle. Right, and I'll explain why that is at the end of this. And then to solve for angle B, I need to multiply this 8 over to the other side. Right, and if you watch the videos that I did on the law of sines, you would have seen problems very similar to this. And if you haven't seen the stuff about the law of sines, what I just wrote up here probably doesn't make any sense to you. So maybe pause this, go watch the videos on the law of sines, and then you'll see what we're doing here. All right, so it's the sine of an angle over its opposite side is equal to the sine of any other angle over its opposite side. That's what the law of sine says. All right, so I get sine of B, sine of angle B equals 8 times sine of 17.6 degrees over 5. And once again, though, I'm solving for the angle, right? Which means I don't just do this in the calculator. I don't do sine of all this stuff. To cancel out the sine here, I have to do this inverse sine function on both sides of the equation. Right, so I get angle B is going to be sine inverse of all this stuff over here. Right, just like I said a couple minutes ago when we were using the law of cosines to solve for an angle, whenever you're solving for an angle, you have to use the inverse trig function to make that happen. Right, it's one of the key things that students often miss when you're doing a problem like this. Right, so now I can do angle B is the sine inverse of 8 times sine of 17.6, all of that divided by 5, and then close the parentheses for the inverse sine function. So I type it in like that, and I hit enter, and I get 28.9. All right, so angle B equals 28.9 degrees. All right, so let me fill that one in up here. All right, so angle B is going to be 28.9. Not too bad. All right, so there's my angle B. All right, so I got angle B now. So angle A, remember, I got using the law of cosines, because when I start with no angles at all, if I only know the 3 sides of the triangle, I have to use the law of cosines to get one of my angles, and you just pick whichever angle you want to solve for. Once I get one angle, though, and I know all the sides, then I can use the law of sines to get the next angle. But remember what I said, you always go for the smaller angle before the larger angle. Right, and I'll show you why that is as we finish this up. Once I get 2 of my angles, though, well, the 3 angles of a triangle have to add up to 180 degrees. So if I do 17.6 plus 28.9, that gives me 46.5. Right, so I have to do 180 minus 46.5, and then that's going to give me the measure of the last angle, which is 133.5 degrees. Right, so in a situation like this, the quickest way to work through the problem is use the law of cosines to get your first angle, and then you can use the law of sines to get the next angle, and then just make the 3 add up to 180 to get that third angle. Right? Your other option, you could use the law of cosines to get all 3. So like what we did for angle A, you can repeat that process to get angle B, and then repeat the process again to get angle C. If you want to do that, that will also work. That'll be a little more time consuming though compared to what we just did. Right, especially for that last angle, where all we had to do was make sure all 3 of them add up to 180. All right, now, why do we not go for angle C when we use the law of sines? Let me show you what happens if we try that. All right, so if I do sine of 17.6 over 5 equals sine of angle C over 12. Right, so just like what we did when we solved angle B, but now I'm going for angle C. All right, so I put the C there. So I multiply the 12 over. I'm just going to real quick, skip a couple steps. I'm going to have sine inverse of 12 times sine of 17.6 over 5. That's going to be what angle C is. Right? I'm going to multiply the 12 up here, and then to cancel out the sine, I have to do the sine inverse function just to save us a minute to do these steps here. All right, so I do sine inverse of 12 sine, and if you didn't quite catch what I did there where I skipped that step, go back and look, when we solve for angle B. I'm doing the same thing, just kind of skipping one of those middle steps. So when I solve for angle C now, I get that angle C is 46.5. Right? Angle C is 46.5. But wait a second, right? 46.5 degrees. But when we solve for angle B first and then made them add up to 180, angle C actually equals 133.5. So what's going on? Well, remember, when you do the inverse sine function, if you remember the stuff if you watch the videos that I did on the inverse trig functions, the inverse sine function only gives you values between negative 90 degrees and positive 90 degrees, right? It only comes from that right half of the unit circle. So if your angle that you're looking for is bigger than 90 degrees, inverse sine is not going to give you that answer. It's going to give you the corresponding angle that's in the first quadrant, which would be 46.5 degrees. Right? Notice if you do 46.5 plus 133.5, those add up to 180, right? Those are those supplementary angles, and they have the sine. If you do sine of 46.5, it's going to equal the same thing as the sine of 133.5, but the inverse sine function only gives you values that are less than 90 degrees. That's why when we're using the law of sines to solve for an angle, we never use that to solve for an angle that might be bigger than 90 degrees. We always have to go for that smaller angle first, like we did here.